So the next question here is an AHP question. We're comparing three alternatives, three hotels in this case, Marathon, Shilton, Chariots, with respect to ambience, location, cost, and comfort. So we have the pairwise comparison matrices for these three alternatives based on those four factors. We also have a pairwise comparison metrics for different criteria. So just to remind you guys, when we the numbers actually on these matrices can scale from 1 to 9, right? So 1 being equally preferable, 1 being actually extremely favorable and extremely preferred compared to the other one. So on diagonal, we always have 1, and then when we have a number, integer number, right on the other side, the exact opposite side, we see inverse of that number. So and then when we have a number that is greater than 1, that means the alternative that is in the row. So for example, 3 here, that would be row and column here, row Shilton, column Marathon. So 3, that means the number in row is more, sorry, the alternative in row is more preferred than alternative in column. Shilton is more preferred than Marathon when it comes to ambience. But when you look at location, again, same comparison, Shilton versus Marathon, you see it's 1/5. So here it says Marathon is more preferred than Shilton, and here it says Shilton is less preferred. And again, the scale here is 5 compared to 3. So the difference between Shilton and Marathon is wider in location than in ambience, even though like one is more preferred than the other one in one factor and the opposite in the other factor, but the difference in preference is also different. As you can see here, one is a little more preferred, the other one is much more preferred than the other one. All right. So in order to create an overall ranking, we need to get scores of each factor, scores of each alternative in each one of these factors. And then we're going to do exactly the same thing for criteria matrix. So in order to get the weights, we need to first normalize the matrices and then take the row average. In order to normalize, we need to divide each cell by the sum of each column. So I already put the tables and matrices in Excel, and I also calculate the sum of each column. All of these values are in fraction format. Here. You can change it. You can make sure that all these numbers are in fraction, are displayed in fraction format. Okay, to normalize, I'm gonna need exactly same headers. So I just Control C, maybe at the end. Yeah, that's fine. Yeah, Control C, and I just paste it here, but I'm gonna calculate. So the formula that it goes here is gonna be the cell divided by the sum of column. All right, and before I do that, I just wanna make sure that all of my values are in number format, just so I see them in decimal form. So, okay, so the first one is gonna be cell Yes, so I had a little bit of issue with my microphone, so I changed my microphone, so it should be good now. So yes, so the formula is not copyable. I just add a $sign to the sum here, denominator here, and then it should be good. So as you can see, B4 divided by B7, and I fixed row 7 by adding a dollar sign here. So this formula should be now copyable. All right. So as you can see now, the sum of weights is 1 for each one of these columns. And I can copy and paste these formula for all of these factors. For the last one, I need to make sure that my formula is correct, because that is good actually. 1 divided by 6 over 6 1/4. I just need to update the formula. All right, so everything is good. All the values are updated. Yep, 1 divided by 2, 5 over 6. It's perfect. So now I got every value in my table normalized. Now I need to, in order to get the weights, preference metric, preference vector for each column, I need to take the row average. Okay, I need to take the row average, and I need to do it for, and again, row average, and I boldface this. So, okay, Control C, Control V. Let's just add a little space here, add a little space here, Control C, and again, Control V, add a little space here. And again, notice the sum is going to be 1 again. Sum of the preference vector. This one, I just want to make sure that I'm counting all 4 values in the row. And again, drag it down. Okay, and again, some of these should be 1, right? Which is the case right now. Yes. All right. So I have all the preference vectors calculated. Now, in order to get the overall score, I'm gonna take the weighted average of the scores based on these preference metrics. So let's just copy this first. Usually that's a good idea, just to bring that closer. Just put it here. Maybe that was a better idea if we also copied the headers criteria. Yeah. Okay. Okay, so, and then for the overall score now, overall score for each one of the factors, for each one of the alternatives would be the weight for ambience fixed times the marathon score in ambience plus the weight of location fixed or locked by adding the dollar signs times its score, marathon score and location, plus the weight for the cost fixed times marathon score on the cost plus the weights of comfort F4 or Command T in order to fix it, multiplied by marathon's weight on comfort. All right, and then you can drag it down. And I'm gonna bring this, again, write down the values in number format, just so we see the decimal values. And then again, the sum should be 1, as you can see here. So this is the overall score. Now, whichever option that gets the highest score gets rank 1, rank 1, rank 3, rank 2. So this is going to be the first choice here, Marathon. So because we got the highest score, highest composite score, Marathon Hotel, right? So that's why this one is selected. And now, okay, so that answers part A of this question. Develop an overall ranking of 3 hotels using AHP to help Jessica decide where to hold the meeting. Okay, so that's it. Check for consistency for criteria metrics. Is it consistent? If not, what is causing the inconsistency? Okay, let's go ahead and check the consistency or inconsistency for the criteria metrics. So this is the only one that we need to check. I mean, of course, the process is the same. If we needed to do it for other ones, we could have. So this is how it works. We are going to multiply the criteria matrix, which is this one, by the preference vector. So the first value, the first row by this column, 1 by 1, all right? And then second row, second value, second, right? So that is gonna give us a vector again, because this is 4 by 4. When we multiply by 4 by 1, it's gonna give us a 4 by 1 vector. So let's just do that. Now, consistency check. Okay, this is gonna be a, like I said, it's gonna be 4 by 4 multiplied by 4 1 by 1. It's gonna be a 4 by 1 vector. So I'm gonna use mmult function, m matrix multiplication metric function. So it's an array function, 4 by 4, comma 4 by 1 preference matrix. Control Shift Enter. Next step, we need to divide this, and let me just type this. Okay, next step, we need to divide these values that we got with their corresponding preference element right here, 1 ambience divided by 0.21. And same for the other ones, right? Again, it's probably better if we write the values in number format. So ideally, all of these values should be equal to 4, because 4 now is the number of cases, number of alternatives. All right. So now I'm just going to refer to the slides here. So we're going to calculate, in order to calculate the consistency index, we're going to take the average of those 4 values, then subtract n being 4, number of alternatives, divided by 4 minus 1. So let's go ahead and calculate CI. Okay, CI going to be average of these 4 minus n being 4, divided by parenthesis 4 minus 1, or 3, and just type it. Make sure to add the first parenthesis here also, open parenthesis, average of these 4 minus n being number of alternatives, 4 divided by n minus 1, 4 minus 1. So that is CI. All right. CI. And then RI, random index, that is something that we need to read. And by the way, let me again change this to number format. So for RI, we need to read it from the table here. So since n is 4 criteria, Ri is 0.9. So we just read it from the table and write it here, 0.9. All right, next step is to calculate Ci divided by Ri, see what is the relative error. And if it's below 10%, we're done. If it's above 10%, that is a red flag. So this one is 11%, a little over the acceptable threshold. So we can flag this and say it shows inconsistency, right? Because Ci over Ri is above 0.1. But now, I mean, it's not that bad, but let's see if we can find the reason behind the inconsistency. So first off, this one actually comfort is a little higher, as you can see, compared to the other one is when you look at the variation, this one, like I said, ideally we want all 4 of them to be 4 exactly, but now we see this one is a little higher. And now let's check to see if we can find out what's causing this inconsistency. If you catch one, that would be enough. So if you remember, I said this is the only thing you need to check. If A is greater than B and B is greater than C, then A should be also greater than C. I mean, and it should be, the difference should be meaningful, right? If A is better than B, B is greater than C, A should be better than C, but the difference between A and C should be greater than the difference between A and B and C. So it's like, it's not the exact sum, but I mean, because it's subjective and all these numbers are pretty like qualitative valuation, right? But it has to make sense. So let's take a look. This is the logical condition that has to hold. So let's say comfort is more preferred than ambience. Location, let's just pick this one, comfort compared to. Yeah, and again, I said, since I said this one is a little more um, uh, like compared to 4, which is our target, is a little the difference is a little higher than the other one. Let's focus on this one. So comfort is more preferred than ambience. Comfort is also more preferred than cost. But as you can see, based on these numbers that we have, the difference between the preference of comfort and ambience is bigger than the difference between comfort and cost. As if like comfort is here, and then cost is closer to comfort, right? Cost, and then ambience, right? So comfort is more preferred to cost, but comfort is even more preferred to ambience, because we have and comfort actually is equally preferred to location, as you can see, equally preferred to location. Comfort is a little more preferred than cost and a little more preferred to ambience. So it's like this: comfort, location, cost, ambience. But let's take a look at these two, cost and ambience here. So based on when we compare cost and ambience here and here, now this is inconsistent. This says ambience is now way more or more preferred than cost from row 1. This is row 1, 2, 3, 4, row 4. That's what we get. In row 1, for when you look at ambience, what we see here is ambience is more preferred than cost. less preferred than location, less preferred than comfort, right? So in here we see comfort is greater than location, greater than ambience, and ambient is definitely more preferred than cost. So it's again, so row 4, we said cost is greater than ambience. In row 1, ambience is greater than cost. Comfort and location, when you compare, I mean, you have to compare one. So here we said they're equally, location and comfort equally, so that's fine. But again, you see here the inconsistency. When you look at cost and ambience, it's just the opposite. The basically when you make the comparison, so there's inconsistency in conclusion in comparison between these two factors. So if you just point out to this one, this inconsistency, that would answer this question.